Okay, so our new unit is going to be over triangles, and we're first going to talk about the triangle sum properties. Let's get a definition of a triangle. So a triangle is a polygon with three sides, and a triangle with three sides and a triangle with vertices ABC is called triangle ABC. So you write out the word when you name it, or you can use the symbol and say triangle ABC. And just in case we're confused about this word, polygon, all that means is that it is a figure with many sides and it is closed. Multi-sides, it's closed shape. Okay, so three sides and they all touch, everything's closed up. That's just what polygon means. So the first one we talk about is a triangle, then we'll go square, rectangle, so forth and so on. Next, how we classify triangle by its sides is we can say, all right, that the triangle is scalene. And what scalene means is that no sides are congruent. And you can see in the picture here that nothing is marked congruent, so none of these sides are the same length. No matter how much they look like it, they're not congruent. Another way is here in this picture, you can see that there are two sides marked congruent, so this is called isosceles. And basically isosceles is if you have two or more congruent sides. And the last one will be equilateral. And this is that all sides are congruent. And what the little kind of catch about all this is, if you notice the definition of isosceles is two or more sides congruent, then we can also name this equilateral triangle, we can also say it's isosceles. So it would be isosceles and equilateral because it has two or more. The next way we classify triangles are by their angles. So we can see here all of these angles inside this triangle. If we were to measure them, they would all come up to less than 90 degrees. So this is called an acute triangle. So we have all the angles, okay, are less than 90. Then we have here in this triangle, you can see we have one angle that's exactly a right angle. So this is called a right triangle. And it has one 90-degree angle. This triangle here, you can see this angle here is pretty large. It's going to measure more than 90, so this is called an obtuse triangle. And all you need to be an obtuse triangle is you just need one angle that's going to be bigger than 90. So only one angle has to be, all right, greater than 90. And the last one, you can see here that all these marks, again, remember those are very important, that means that all of these angles are congruent. So since we have up here, you notice all three sides are the same, we call it equilateral. So in this one, when all three angles are the same, we call it equiangular. So all angles are congruent. Now, once you have, if you have something that's equilateral and equiangular, you have one or the other. So these two words, equilateral and equiangular, they always are pretty much seen together. So basically, if all the sides are congruent, then all the angles are congruent. And you can also take the converse of that as well and say if all the angles are congruent, then all of the sides are congruent. All right, so next we're going to talk about angles inside and outside of a triangle. So when you have the sides of a triangle, when they are extended, there are other angles formed. So you can kind of see out in these pictures down here, we've extended the sides even though we still have a triangle here in the middle. So that's what it's talking about, extending the sides out beyond the triangle. So basically the original angles that were in the triangle and here, okay, these are referred to as the interior angles. So all of these in here, like I said, these are the ones that are interior angles. And I'm not saying these are all congruent, I'm just kind of shading in the angles, okay? They're on the interior. Okay, and then the angles that are formed on the exterior, and those look like, so all these angles that are formed on the exterior out here, okay, when those angles, what happens is those angles are forming a linear pair, so there's that word. Remember I told you it's never going to go away? It's forming a linear pair with the interior angles are the exterior angles. So basically what you need to, again, pay attention to is we always will have linear pairs. So we have right here and here, we have a linear pair. We have this exterior angle in the green one, and then we have an interior angle in the red one. And together they're sharing that line. Again, here, have a linear pair. We have an exterior angle, and we have this interior angle right here. That's a linear pair. Or we have these two angles right here and here, okay, those form a linear pair. So exterior angles form a linear pair with the interior angles. Now, the next thing we're going to use this a lot. It's called the triangle sum theorem. These sums, so remember that means if you add everything up of the measures of the interior angles of a triangle is 180 degrees. Remember, that's probably our favorite number right now. So everything inside of a triangle adds up to 180 degrees. So if I were to take the measure of angle A and add it to the measure of angle B and add that to the measure of angle C, they would all add up to 180 degrees. So basically that's talking about all of these angles in here. If you were to measure A, measure B, and measure C and add all of them up every single time inside of a triangle, you're going to get 180 degrees. All right, the exterior angle theorem is the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So there's that word non-adjacent again. Remember I told you everything builds. So you have to make sure you remember everything prior to this because we still got to remember what all of these words mean. So we look through this again. The measure of the exterior angle, which is right here where this one is sitting, the measure of this whole angle is equal to the sum of the measures of the two non-adjacent interior angles. So if I'm looking at angle 1, this angle right in here, that's adjacent to it, okay? So that would be adjacent right next to. What we do, though, is we take the two non-adjacent ones. So if we're looking at angle 1, the two that are not adjacent are the ones not touching it. It's kind of like totally diagonal from it. Those are the two non-adjacent ones. So this angle in here and this angle in here, if I were to add those two together, I get the angle on the outside. So the way that looks is the measure of angle A plus the measure of angle B is equal to the measure of angle 1. So again, these are the two, these are interior, the non-adjacent interior, and this is the exterior. And I always say the two on the inside equal the one on the outside. But again, that's a little short. You got to remember that's the two non-adjacent ones. All right, the last little theorem we're going to use is called the corollary to the triangle sum theorem. And I know this is a kind of a silly word, and I don't want you to get all caught up on it, but really a corollary all it is, let me spell it correctly. All that term really means is that it's resulting from something else. So it naturally follows, kind of like it's common sense. So naturally follows from another thing. So like I said, it's common, like, just think of it as a corollary means it's common sense. So basically the corollary to the triangle sum theorem says that the acute angles of a right triangle are complementary. And this is going to make sense to you. You're going to say, well, duh, no, you know, I know that because we already talked about that everything inside of a triangle adds up to 180 degrees. Well, if you have a total of 180 degrees and you have a right triangle, that means 90 is already spoken for. Then you only have 90 left. This 90 left is for the other two acute angles. And remember, complementary means that two angles add up to 90 degrees. So it's just kind of like common sense. We know everything in here is 180. If I take away 90, then yes, only 90 is going to be left for the other two angles. Now let's look at, all of this in examples of problems you're going to see. So again, if you would like to try this on your own, you can pause it here and then come back and check, or we can work, through them together. So in the number 1, find the measure of angle JKM. Well, first I want to make sure we know where that measure is of JKM. So if we go from J to K to M, it's this angle right here. So identify the angle and then ask yourself, is it interior or exterior? Well, that angle there, this is an exterior angle. So that means we're going to use the exterior angle theorem, which says the angle on the outside, right here, is equal to the sum of the two non-adjacent ones. So again, listen to my words and watch me write the equation. Remember, I told you it's all about taking the idea and making an equation out of it. So we have the angle on the outside. Right? That's the angle on the outside. It equals the sum of the two on the inside. So that is taking that theorem about the exterior angle and making it into an equation. The one on the outside equals the sum of the two non-adjacent. And then once you got that, you just go through and solve. So subtract x from each side. And we have all gotten to be pros at this. 70, then add 5 to each side. So x is 75. Again, let's make sure we read our question because it actually wants us to find the measure of this angle. So we don't just need x, we have to actually take that x and plug it back in. So we have 2 times 75 minus 5. So 75 times 2 is 150. So 150 minus 5. So the measure of that angle is 145 degrees. So that's how you apply the exterior angle theorem. Okay, number 2, find the measure of each interior angle of triangle ABC. So remember, when there's no picture, we're always going to draw one. So we have triangle ABC. And when you're naming a triangle, it doesn't matter which vertex you start at. I typically start in my bottom left, but that's just where my eye and pencil go. You don't have to. You can put the A anywhere you want and just make sure you go around in a circle. All right, so we have that they're giving us, so find the measure of each interior angle of triangle ABC, which we drew, where the measure of angle A is x. So right now, this x is representing the measure of angle A, 2x is representing the measure of angle B, and 3x is representing the measure of angle C. And we have to find the measure of each angle. So remember again, here's that buzzword find. So find means we need an equation over here. It's your responsibility to know how to set that up based on this theorem right here. So we learned about interior angles that the sum of all of these angles equals 180 degrees. So that's what that theorem told us. So watch. The sum of all the interior angles is 180 degrees. So that's how that theorem turns into an equation. Again, here we go. I told you we do the same thing all the time. We combine like terms. 1 plus 2 plus 3, that gives us 6x. Divide by 6. So our x is 30. And again, I remember it actually wants to find the measure of each angle. So I have to take this 30 and plug it back in to all three of these. So to find the measure of angle A, that is x times 30 times x is just going to give us 30. So the measure of angle B is 2 times x, which is 2 times 30, which is 60. The measure of angle C is 3 times 30, 90. So you can always check your work here. Make sure you did the algebra correctly, because remember, all of these should actually add up to 180 when you're all finished. And this is 30 plus 60 is 90. 90 plus 90 is 180. So yes, check, we did this correct. Number 3, find the measure of the acute angles of the right triangle in the diagram. So this is the corollary of the right triangle. It told us that the two acute angles in the right triangle, because remember, this one is not acute, this is right. These smaller ones are acute, that these two acute angles are complementary. So we're going to put that into action. The two acute angles are complementary. So again, taking that theorem, turning it into an equation. Same old, same old. 2 plus 1 gives us 3x. Add 6 to each side. So 3x is 96. And then we have to find, all right, x is 32. But again, it wanted the measure of the angle, so take the 32 and plug it back into each spot. So 2 times 32 is going to give us 64 degrees. And then if we have 32 minus 6, that's going to give us 26 degrees. So those are the measures of the two angles. Again, check your work. The corollary of the right triangle says that the two acute angles are complementary. Are your angles complementary? Yes, this adds up to 90. If these don't add up to 90, then something happened over here. You need to go back and rework. All right, one more. So we need to classify the triangles by sides and angles. And the most common thing that happens here is students just do one or the other. You pay attention to the instructions. This wants both. So we went by sides and angles. So remember, by sides is scalene, is none or congruent. Isosceles is 2 or more, and equilateral is all. That's by sides. By angles, we have acute, obtuse, we have right, and we have equiangular. So those are our words we're choosing from when we're classifying by sides and angles. So if we look here at this triangle, if we look at the sides, there are 2 marked congruent. So if 2 are marked congruent, we call that isosceles. Now let's look at the angles, and I notice that there is 1 right angle, so that makes it an isosceles right triangle. Number 9, all 3 sides are the same. So if all 3 sides are the same, that's an equilateral triangle. But also, the definition of isosceles is 2 or more. So this is also called isosceles. And all of the angles in here, if I were to measure them, they're all going to be less than 90 degrees. So this would be an equilateral isosceles acute. And again, it doesn't matter what order you write all of these things in. There's no right or wrong answer. You can say isosceles right or right isosceles. This one I would probably say this is an acute equilateral isosceles triangle, but it doesn't matter. As long as you have all of the descriptive words there, you're good to go. Okay, number 10. None of the sides are marked the same length, so that is called scalene. So this is a scalene triangle. And this one angle right here is really, really, really big. So that's going to be obtuse. So this triangle is a scalene obtuse triangle.